Okay, let's go ahead and wrap this up. We're going to do some conversions. Let's look at number 13, 110 degrees to radians. So I want to go from degrees to radians, which means, if you remember, there's pi radians in 180 degrees and 180 degrees in pi radians. So I'm going to multiply my degrees by a ratio of those two to do my conversion. So 110 degrees times, if I want to go to radians, I want my radians in the numerator, I'll put the degrees in the denominator. Remember, your units cancel out. We are left with 110 over 180 pi. And now all I need to do is just reduce my fraction. Notice numerator and denominator can be divided by 10. We get 11 pi over 18. Let's go from radians to degrees. So I'm going to start out with 9 pi over 10, my radians. I want degrees, so I'm going to put degrees in the numerator, divided by pi. And now I can see my pi is going to reduce out. I can cross reduce here. 10 goes into 80. Be left with 18. I get 9 times 18. And that is going to be 162 degrees. 15, evaluate cosine of pi. Okay, so whenever we are evaluating these trig functions, we are looking towards those ordered pairs that fall on the outsides of the unit circle. And if we're in a unit circle, we know that the radius is 1. One is a unit. So let's find pi. Well, here's 0, pi over 2. Here's pi. Now, think of this too. We have cosine of theta, sine of theta. That's your ordered pair, which also relates to x and y. If I have a radius of 1, okay, what would your x value be? Remember, think of this as a coordinate plane. It would be -1. So that point is -1. Your y, if you're on the x-axis, it's 0. So that means cosine of pi equals -1, sine of pi equals 0. Now let's look at sine of pi over 2. Here's pi over 2. Remember, sine relates to y. I have a radius of 1. So again, radius, you're going around the unit circle here in my quadrantal angles. Makes it super easy. My x value, I'm on the y-axis, so it's 0. My y value, I'm above the x-axis, radius of 1. This is a +1. So in other words, the cosine of pi over 2 is 0. The sine of pi over 2 is 1. Let's kick it up a notch. Sine of 11 pi over 6. Here's where your reference angles are going to come in very handy. Makes life super simple. Okay, so my reference angle. Radians are great. All you do is look at your denominator. And if you remember too, this comes from another video lesson that I did. Right here are your common reference angles and their values. So if we have a 6 in the denominator, your reference angle here is pi over 6. And if my reference angle is pi over 6, here's my ordered pair, square root 3 over 2 and 1/2. Okay, what quadrant am I in? Well, 11 pi over 6. Here's 0, pi, 3 pi over 2, 2 pi. Well, if I rewrite 2 pi with a 6 in the denominator, that is 12 pi over 6, right? 12 divided by 6 is 2. Isn't 11 pi just right before 12 pi? So that means we are in quadrant 4. And so if we're in quadrant 4, is sine positive or negative? If we're in quadrant 4, we are below the x-axis, so sine is negative, which means sine of 11 pi over 6 equals negative 1/2. There's my sine value. Just make make it negative if it's in quadrant 4. Let's do cosine of 210. Let's figure out what quadrant we're in first. 210 degrees. We're 0, 90 degrees, 180 degrees, 270 degrees. Okay, 210 degrees is between 180 degrees and 270 degrees. So that means we are in quadrant 3. And is cosine, your x values, are they positive or negative in quadrant 3? Well, they are negative. Let's find the reference angle. And again, because we've gone past 180 degrees, my reference angle is going to be how far past 180 did I go? 210 degrees minus 180 degrees equals 30 degrees. Okay, so now let's look at the chart. 30 degrees, my ordered pair is square root 3 over 2, 1/2. Here, that is cosine. So the cosine of 210 degrees equals negative square root 3 over 2. When it comes down to doing this on your actual test, I actually broke the questions down into 3 steps, so you will not have to show this work. You will have to answer each of these questions. Number 19, now we're going to find sine and cosine. So let's do them both. 315 degrees. Let's start out with quadrant. 315 degrees is greater than 270 degrees, but it's less than 360 degrees. So we're in quadrant 4. And if we're in quadrant 4, cosine is going to be positive, but sine will be negative. So let's find the reference angle. 360 degrees minus 315 degrees, 45 degrees, which again gives us that lovely chart. Go back here, square root 2 over 2 and square root 2 over 2, the nice easy one. Square root 2 over 2, square root 2 over 2. Okay, so that means the cosine of 315 degrees, here's cosine, cosine is positive, square root 2 over 2. Sine of 315 degrees, but sine is negative. Okay, last one. Pythagorean identity. Make sure in your work you're showing the use of this formula. Remember, theta can also be x. So cosine of theta equals what if sine of x equals negative 24/25 and is in quadrant 4? Let's jump in. I'm going to plug my values into my formula. I'm going to have a negative 24 over 25 squared plus cosine squared x equals 1. Let's simplify. Negative 24 squared is 576. 25 squared is 625. I'm going to subtract from both sides. And this can be written as 625 over 625 minus 576 over 625. Cosine squared x equals 49 over 625. Square root both sides. Cosine of x equals 7 over 25. Cosine is positive in Q4. Final answer.